In this video, we're going to discuss the energy balance on Earth and how that's affected by the sun. So, almost all of the energy used on Earth to sustain life and cause our changing weather systems comes from the sun. It's the source of Earth's energy. It's necessary for plants to grow and for humans to survive. It helps keep land, water, air warm enough for things to grow and for things to thrive. Without the energy from the sun, certain plants wouldn't be able to grow, and the land and air and water would not be fit for human survival or for the survival of many different animals and plants. Almost all of us use this energy in some form, whether directly or indirectly. Plants use it directly via photosynthesis, and then humans use it indirectly, sometimes by eating those plants or the animals that have eaten those plants. And then we also use the sun directly through, vitamin D and all that heat and warmth to kind of keep our bodies where they need to be to thrive on this planet. On average, the surface temperature on Earth is between 14 and 15 degrees Celsius. Of course, that's a global average. Near the equator, it's much warmer, and then near the poles, it's much colder. If you were to take an average near the equator, you're going to get some places where it can be up to or over 55 degrees Celsius. And if you go to the poles, you're going to get places where it could be as low as minus 90 degrees Celsius. There is a delicate energy balance on Earth that must be maintained. If the energy that is absorbed by the Earth is greater than the energy that it gives off, then the Earth will heat up. And if the energy absorbed by the Earth is less than the energy that it gives off, then the Earth will cool down. This balance is very important, and it is quite delicate. So taking a look at this figure here kind of gives us an idea of how the energy that comes in from the sun is dispersed around the Earth. So we can see that about 30% is immediately reflected back, and that's reflected back through by the atmosphere, by the clouds, or by surfaces on the Earth. The remaining 70% is initially absorbed by the Earth and then does, of course, radiate out over time. So we can see here that just over half, so 64% of that total energy is radiated to space through the clouds, atmosphere, and indirectly from Earth. About 6% is radiated to space directly from Earth. There's portions that are absorbed by the clouds, there's portions that are absorbed by the land and the oceans. And this delicate balance of energy being absorbed and then being reflected back is very important. As we talked about before, if that balance is thrown off, then the Earth will heat up too much or it will cool down too much. And of course, either case can be detrimental to both plant life and wildlife and humans alike. When energy from the sun reaches the Earth and comes in contact with a particle, say a gas particle in the air, for example, then there are a couple options that might happen. The energy could be absorbed by the particle, which will cause it to gain energy. Lots of particles are really good at absorbing sunlight. It might be transmitted right through the particle, meaning it passes through, and it's going to keep passing through until it hits something that will absorb it, or it'll hit something that will reflect it. And that's the third option. That energy from the sun might be reflected off of a particle, and then it will go back into space, or it might be reflected off into another particle. If we take a look at Earth's climate systems, then we talk about a couple new terms here. So we're going to talk first of the atmosphere. So what is the atmosphere? The atmosphere is all the gases that surround the Earth. This includes the air we breathe and as well as much higher up. The atmosphere does extend for quite a distance, and we'll talk more about that, I think, in the next video. The hydrosphere is all the water on Earth. This includes liquid water, like our oceans, solid water, ice, like the polar ice caps, and of course water vapor, like the water vapor in our atmosphere. Next up is the lithosphere. These are all the land surfaces, rocks, any relief formations, or even Earth's crust. And then lastly, we talk about all the living things. So all the living things, plants, animals, and even things that we can't see, microbes, microbacteria, a lot of small things that might live in water, for example. And all of these climate systems, to some extent, are affected by the sun. The energy that Earth receives from the sun interacts with all the components of our climate systems and contributes or produces thermal energy. Finally, let's quickly discuss the latitudes of Earth and how that may affect the climate zones. We talked about climate zones earlier in a previous video, and we did mention how they are somewhat related to latitudes, although not always exactly how you might predict. So why is it warmer at the equator? Well, if we look at this diagram, we can see that when energy comes in from the sun and it hits an area near the equator, it's very concentrated. And so all that energy kind of stays in a small area. And that's the figure on the left. If we take a look at the figure on the right, when energy comes in from the sun and it hits the poles, well, then we see that it's spread out over a much larger area. That means the intensity is a lot less. So this generally explains why near the equator we have warmer temperatures and near the poles we have colder temperatures. You might also notice from this picture that Earth is tilted a little bit. Earth axis is tilted a couple of degrees, and this explains why our climate zones from the previous video aren't exactly where you might expect them to be latitude-wise. We do count latitude starting from the equator, but since Earth is tilted, that doesn't quite match up. And this tilt actually helps to explain why the climate zones don't kind of radiate symmetrically out of the equator.